Now that we've talked about the structure, functionality, key methods, and example applications of ReentrantReadWriteLock, we're going to take a look at its usage considerations to understand how to apply it effectively in practice. It turns out that ReentrantReadWriteLock does in fact enable higher levels of potential concurrency when accessing shared read-only data compared to a reentrant lock that we talked about earlier. And therefore, you may be able to get a performance boost if the data protected by the lock are read from much more often than they're written to, particularly on multi-core systems. However, ReentrantReadWriteLock has a number of limitations, some of which are fairly significant. Both read and write locks are pessimistic, which means that they always have to acquire the lock. This is, of course, in contrast with a stamped lock, which, as we'll see later, also supports something called an optimistic remode. As a consequence, the overhead of ReentrantReadWriteLock is often much greater than its benefits in practice. Another problem with a ReentrantReadWriteLock is it can starve readers or writers, depending on the priority that's given to them by the implementation. For example, in Java 5, readers were given preference, whereas in Java 6 and beyond, writers were given preference. So this leads to confusion and it leads to inconsistency as well. It can also be tedious and error-prone to program a ReentrantReadWriteLock. In particular, all the same problems we saw before when we were talking about ReentrantLock and Java Semaphore are also problems with ReentrantReadWriteLock. For example, you may acquire a lock and then not release it or forget to release it. You may acquire a resource without holding a lock. You might release a lock that was never required. You could hold a lock for a long time without needing it. All those same problems we talked about before are also problems for a ReentrantReadWriteLock. So as a good rule of thumb, it's very important to profile your code carefully to see if you actually need a ReentrantReadWriteLock. And I would recommend in practice trying to use stamped lock whenever you think you need to use a ReentrantReadWriteLock. So that's the end of our coverage of Java ReentrantReadWriteLock, and we'll now start talking about stamped lock, which is the alternative approach, and ideally a much better approach in many situations.